Okay, so in this video, I'm gonna discuss to you how to overcome these questions. It's all about the organic chem. In this video, your understanding in terms of substitution nucleophilic reaction and mechanism is essential. And in this video, I'm gonna demonstrate to you how you can actually accomplish these questions in less than 5 minutes, right? So in this case, we have nitrosyl chloride, NaOCl, and it is a reactive gas that sometimes form when NO reacts with Cl2. So the chemical formula of NaOCl, nitrosyl chloride is given here, and then we have structure that we have nitrogen is a delta plus, and Cl is actually negative dipole. All right. If you don't know why N in this case is actually plus and the other one is negative, um, I will give you short explanation. So the only thing that you need to remember or to do is actually check on your periodic table. So you check on your periodic table which of these two would be uh, more electronegative. All right, so the keyword is actually the electronegativity. All right, so the more electronegative, meaning the more electron goes toward that side. So in this case, if we compare nitrogen and chloride, chlorine, chlorine is located in group 7, while or 17, while nitrogen is located in group 15. Meaning, if you remember the trend of the periodic table from left to right and from the bottom to top, the value of electronegativity is also increases. So that's why I just put this sign. So from bottom to top, from left to right, meaning from the metal to non-metal, the value of electronegativity increases. So this actually I just put non-metal, right? So of course, if you study this one carefully, all right, so then you will be able to assign uh, the dipole, all right? And then if you look at the structures of ethene, so if you know this one's actually ethene is actually unsaturated hydrocarbon, so HC, all right? So hydrocarbon, so meaning they would have one is actually sigma and the other one is actually pi. And the reason why we have one sigma and one pi is basically because in this case, carbon has uh, unused electron. In this case, this electron of this carbon number 1 and this dot electron from carbon number 2 overlaps, then definitely they create a new bond which is weaker, all right, which is weaker than the one that we have here in the sigma. So I just write here for your understanding. So pi, so in this case pi is actually pi bond is weaker than the sigma bond. So that definitely the sigma bond comes from the overlapping between two electrons. So when they these two electrons merge, then you're gonna have a new shape of this novel or the hybrid orbital. Then this overlapping between two nucleus, right, increases the strength of the bonding between carbon number 1 and also carbon number 2. All right. Now, having said that, so basically we can show you. All right. So I'll show you the arrow. All right. So how it reacts. All right. So in this case, after we got this assignment, so of course because Cl is more electronegative than nitrogen, so the electron here between nitrogen and Cl goes to Cl side. All right, so meaning that's why Cl has temporarily excess electron. So Cl has less um, or more number of electron. All right, and then in this case, because we have a pi bond over there, all right, so it will attack this one. All right, so remember, when you draw the line, you should clearly start from these positions of the line or underneath of the double bond goes to n for you to get a full mark. All right, and as a result, all right, so we can actually write like this. Okay, so when this electron goes there, so meaning this carbon in carbon number 2, let me just put here carbon number 1, carbon number 2, it now this carbon has lacking of electron. All right, so meaning this NO is already attached in carbon number 1. And of course, because this carbon number 1 uses the electron of carbon number 2, um, it will create it will create the positive charge over here in carbon number 2. So you would have this one. All right, so and then this plus charge is attracted to Cl. um, One recommendations for you, I always check what are the required, what equals one required conditions needed in your uh, questions, right? So you need to include necessary charges. So we already have a negative and plus charge, and then you need to show the lone pairs. So over here, so lone pairs. So where is the lone pair? So in this case, you should notice that you have a lone pair of electron in Cl and making it -1. All right, so this Cl now has excess of electron. All right, because this Cl in the previous side takes the electron from nitrogen, making this Cl is -1. And therefore, all right, so therefore this Cl will be attack, okay, or this one will attack the Cl, the C plus, all right, and of course you're gonna have this one. So after Cl attacks, or after Cl gives its electron to carbon number 2, let me just put number 2 and it's actually carbon number 1. Afterwards, then there will be a new bond established. So between C number 2 with Cl, then you would have this one, and then of course between the C number 1 with NO over there, then it gives you this one. So definitely you're gonna have this structure. All right, next let me just give you another example. Right now we're gonna have this reaction between one bromobutane with OH minus, right? And then it produces R. So similar to the previous questions, you are to determine the necessary charges, dipoles, lone pairs, curly arrows, and the structures of R. So how do we do this one? All right. So again, it is important for you to check the structure right here, and then of course your identification on the positions of the atom in this molecule is crucial. Since Br is located in group 17, meaning that Br is more electronegative than the rest of these atoms, all right? So as a result, you can actually assign the charges. So this one is will be -1 or delta negative, and this one, this C will be delta plus. All right. Now, is when you look at this OH, right? So OH is actually located in group 6, so there will be 1, 2, 3, 4, and 5 and 6, right? So 1, 2, 3, 4, 5, and 6. So you would have this OH, right? Okay, so H shares one electron to O, all right, making the OH becomes uh, new bond, right? So there will be bond between H and O. However, you notice here we have a lacking of electron, right? So that's why the -1 charge over here is basically additional atom from the other species, right? Okay, so now since you are required to include the charged dipoles lone pairs, right? So we already have the uh, um, dipoles, right? We have a charge of dipole, which is delta plus and delta negative over here. So it's actually the dipole. And then we have charges over here. So you have -1 charge. All right. And then you also need to show the lone pairs. So in order to eligible for complete mark, you need to show the lone pair of electrons. So here you need to write or include the lone pair of electron. All right. And then later on, you will show the examiner the curly arrows. All right. Now, we can actually put here, all right, so from this bond goes to BR, meaning you explain to the reviewer that this BR takes the electron of C, all right, of the carbon. And afterwards, we would have, because this one lacking of electron or deficient number of electron, so it attracts to this OH. So definitely this OH may join this C. All right. So as a result, we can actually show to you that this OH, all right, this OH joins this group, and of course, you can get this product. All right. So to simplify, I can actually put this one C3H7, but then I just follow the I just copy that one. All right. So CH3, CH2, CH3, and of course, because we can actually visualize this one in three-dimensional structure. So this H will be pointing away from you, and this dash, the this dash line, meaning this H going toward the viewers. Okay, so it's going toward viewers. It's actually away from viewers. All right, so that's actually how you do it. Okay, so therefore we can actually name this product. Basically, you would have um, 4 carbons, so 1, 2, 3, 4. All right. So but then if I number from right to left, then definitely it's actually wrong, because we need to prioritize the carbon atom which attached to functional group. All right. Therefore, it should be this carbon should get the instead of 1, 2, 3, 4, or from right to left. So basically, we can actually uh, convert that one from left to right, because this carbon, which attached to functional group, should get the priority. Again, let me repeat one more time. This carbon, which attached to the any functional group, should get the lowest number of carbon, or should get the priority. All right. So, for example, if you have this one, all right. So, if you study carefully, this is actually the propanoic acid. So our numbering system starts from 1, 2, 3, so from right to left. All right. And then if you got this structure, for example, all right. So let's say you have this. This is actually the ketone functional group. So it's basically um, this structures actually they have symmetry. So this actually 1, 2, 3, or 1, 2, 3. This actually no issue, because if we look at from right hand side or from left hand side, then definitely it will give you just the same structure. So definitely it will not change a lot. All right. Okay. So 1, 2, 3, 4. Then I have 4 carbons. Then definitely I will have butane one all. All right, so the name for the structure will be butanol. All right, I think I've been explaining 2 examples for you. Keep on learning, and enjoy this video and thank you again. Bye bye.